want to talk about microgrids in a couple of minutes, about the concept of the microgrid and the importance of having microgrids in world. So the microgrid, as you can find from the name, is a grid in micro size. So for example, this is a kind of microgrid. So we have buildings, homes, factories, and it's connected to the grid. But in same place, we have solar panels, batteries, wind turbines, and gas power plants. So this system somehow can produce energy, store energy, and use energy at the same place. And it can be operated by grid connection or without any grid connections. So what is a microgrid? So a microgrid is a localized energy system that can operate completely independent with the main grid. So we have storage systems, we have power generations, and we have distribution system in very small area. And if it's not connected to the grid, we can call it island grid or island mode. For example, we can have one power system as a campus or one neighborhood. So how microgrid works during a day, for example, assume that you have a house. So during a day, we produce power from the PV and use for our demand and also charge the battery. And during the night, we use the power from battery for using in power consumptions. So in microgrids, we have different components. We have energy sources, we have storage systems, we have loads, and always we should have this kind of devices as a mandatory devices. So microgrids provide many benefits. So the benefits of the microgrids can be on cost, reliability, efficiency, sustainability, and resiliency. So for reliability, it can provide some backup to the power units. For example, assume that you have a part of the city or community as a microgrid, and when there is some blackout in the main grid, this microgrid can work completely independent to the main grid. And because normally we don't need so much power consumption, power flow from the main grid, it can increase the efficiency of the whole power system. And typically they working with renewable energy systems, so we have lower carbon emissions, and it can also reduce the cost bills, and also the resiliency of these systems is much higher than normal distribution systems. So how is the structure? Normally we have the utility grid that is connected by microgrid controller converters to the PV system, digital generator, and backup. And also we have the connection to the main system. So for example, we have normally a lot of control systems to any renewables to control the voltage and frequency, because this kind of microgrids can be used as islanded mode, so is not connected to the main grid. So the voltage level and the frequency should be controlled completely locally. So a couple of examples, we have the University of Puerto Rico as a microgrid, and this is a campus. Mainly they have generation by PV systems and a couple of batteries. And also we can have some industrial sites. For example, here in Africa, we have one mine because it's really far from the main grid. It was financially better to install a PV and battery systems in that area without connecting to the main grid.